let's get some practice using the equations of motion. Question 1. Starting at 5 meters per second, a car accelerates steadily to 20 meters per second over a distance of 45 meters. What is its rate of acceleration? Now, all questions involving equations of motion refer to intervals. And the first step is to put in everything you know about that interval in this diagram, simple diagram here. So first it says starting at, so that's initial, 5 meters per second. Meters per second is a velocity. So we know the initial velocity is 5 meters per second. A car accelerates steadily to. To means that's final. That's where it ends, how it ends. To 20 meters per second. Meter per second, again, is a velocity. So this is a final velocity. So the velocity at the end of this interval is 20 meters per second. Over a distance of 45 meters. Delta x is 45 meters. Delta x is displacement, but in linear motion, the magnitude of displacement and distance are the same. The next important thing is to determine what we're being asked. What is the rate of acceleration? So acceleration is what we're required to find out. Once we have our diagram here, the next step is to choose an appropriate equation. And there are two things that we have to bear in mind in choosing the right equation. The first one is the required value has to be in the equation, otherwise how are we going to solve for it? So that eliminates this equation as well as that one. The next thing is that any information we have not been given must not be asked in the equation. So we have not been given delta t here, the time interval. So we mustn't have an equation which has delta t in. So this equation is no good to us, and this one, and this one. So now we can see there is only one left. V final squared is equal to V initial squared plus 2a delta x. Now we substitute values into that using our picture to help us. The final velocity is 20 meters per second. Remember to square that. The initial velocity was 5 meters per second. Again, remember to square it. Plus 2. Acceleration is what we're required to find out. So we just write a. Delta x is 45 meters. 20 squared is 400. 5 squared is 25. 2 times 45 is 90a. Now we subtract 25 from both sides of the equation. 400 minus 25 is equal to 25 minus 25 is 0, so we leave that out. 90a. 400 minus 25 is 375, and we divide both sides by 90 to clear 90 from the right hand side. 90 divided by 90 is 1. 375 divided by 90 is 4,17. And that's acceleration's value. The unit of acceleration is meters per second squared. Acceleration is a vector quantity, so we must give a direction in direction of motion. How do we know that? Because this is positive. We don't write the plus there, but it is there. It's just implied, and so that means in direction of motion.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!